Good morning, good afternoon, good evening, everyone joining us across the globe on this special edition of ETAP Tech Talk series. My name is Sheikh Shahid Hussain. I work as a Chief Revenue Officer and Senior Vice President of ETAP. Indeed, climate change is a major concern, and together we must combat the situation. As energy sector contributes around 30% of the global carbon emission, it's necessary ever than before for all of us to look at our energy priorities and take the best approach for the convergence. In today's session, we will discuss how ETAP is disrupting the industry by providing a very unique enterprise electrical management platform which supports for the electrifications, digitalizations, and energy transitions for a sustainable world. Let's get started. As we are talking about the energy transitions, let's look at what are the changes in the energy landscape from a traditional to the energy new outlook. So the traditional energy value chain looks like where you have a centralized generations along with a high voltage transmission, medium voltage, low voltage distributions, and the energy consumers, or the conventional power generations with the standalone power networks, which is being connected to the different users and consumers, which has been what we have been working for a long period of time, and so on and so forth. As the energy transition come into picture because of the emissions, the outlook has changed completely. So the new energy value systems looks like something which is different from the conventional one, where obviously there are centralized generations, the old fossil fuel based systems, and the existing transmission network remains as it is. However, the change is the centralized generation converges from a conventional fossil fuel to more renewable centric generations, where we have the wind, we have the solar, and various hydro and wind and renewable sources of energy generations which has come into picture. And eventually are the distribution side, which was typically used as a distributions. We have the distribution plus the generations, wherein we have various distributed generations which is available, and the consumers are promoted as prosumers, where they are not only consuming the energy but also generating the energy and supplying the energy back to the grid, which is with a grid connected environment or completely an off grid with new clean generations where the source of power is only from the renewable sources or the clean sources. And that energy transitions brings an environment where we have a connections from the plant to plug with a decentralized environment along with a very flexible approach, and finally having a connected orientation. Combination of all of this creates an consumer morphing into the prosumers. So that's essentially the change in the landscape of energy that we have seen from traditional to the new energy segments. And as we are moving through this new energy segments, what are the segment objectives? So the new grid objectives are as follows, where everyone is looking at optimizing the electrical bill and sustainable footprint, where you will be having a hybrid system from a grid, local generation storage and load management along with the grid tied in environment, all the way to the islanded environment where it is not connected to the grid and the hybrid systems is running independently along with the different sorts of clean energy sources, along with the local generation storage and load management. And eventually we have the next one, which is an off-grid environment, which is completely isolated. It forms its own grid and it provides a future proof of the power systems, where you would be having different sources of power generations, mostly from the renewable sources, and eventually the loads and the demand management is happening by locally, and they are forming the grid independently, which is 100% clean and sustainable. So these are the three priorities and objectives which is the new grid is looking at. Great. But as we are integrating with the existing infrastructure, there are various challenges which we look at from a business to a technical aspect for achieving this new objective. So what are those business challenges in the grid transitions? Let's look at. Obviously, the capital cost and time to market is pretty high with respect to the renewable sources, and the renewable energy being one of the pillar to reduce the global carbon emission. We need to deliver with respect to faster and optimized LCOE, As per the various reports, so we are expecting 20x global renewable installed capacity by 2050, which is estimated to roughly around 3.4 billion. So, which is means there is a heavy capex engagement. The O&M efficiency is also a very important aspect where we need to provide highly efficient new energy systems for better optimized operations, as well as having a complete focus on the people and asset safety for a reliable operational efficiency systems. And that's where the LCOE for the related operation and maintenance cost is important to be optimized, and eventually the increased revenue. As we are bringing the new sources of energy generations, the further improvement of capacity factorizations as well as energy migrations to generate the new revenue streams for the industry is important. Hence, as we are morphing towards the prosumerization, spot market, and creating an energy trading environment for renewable assets to monetize the energy markets are key pillars in the business segments. And finally, last but not the least, the grid integration and repowering need to prepare the future power grids. So with respect to critical thinking, where the global share of renewables, both from the wind and solar, will increase by 34% by 2030 and 60 by 2050. So these are the various grid transition business challenges which we see. And parallelly on the business front, we are also looking at the technical risk and challenges which we are expecting from the power generations all the way to the power utilizations, from the conventional sources to the renewable sources of the power plant, where we are expecting different risk for the variability and uncertainty of the renewable energies, impact of the existing fossil fuel generators, and obviously the interconnection complexities from different power plants with the renewable power plants, and managing the whole ecosystems together. And obviously the grid resiliency is because of the congestions and physical limitations on the transmission network which was built ages ago, the regulatory compliance to fulfill the grid code expectations of the utility, as well as the instability and the lack of capacity which many a times runs into on brownout and blackout conditions, which is a major concern. Finally, last but not the least, engaging the consumers. So where we can have the right kind of demand response, so right kind of DER and distributed energy resources, and having a nano grid, microgrid, and mobility management systems for the distribution grids, as well as the end consumers and prosumers. So we looked at the requirement from an energy transition perspective for global climate change that we all want, but it comes along with its business challenges as well as the technical challenges. So what is the solution? And that's where ETAP comes up along with a disrupting technology which is very unique by itself, which essentially known as an ETAP GTDMS. So what is an ETAP GTDMS? It's an integrated system which provides a new frontiers in the digital transformation for a sustainable future. It provides an enterprise level of electrical management systems, converging the conventional generations to the new generations, existing transmission to the distributions to the prosumers, a unique portfolio of offering for converging the generation, transmission, distribution, and microgrid systems together. And as we talk about ETAP GTDMS today, which provides a complete foundations with a digitized informations, where the digitalizations process and roles that makes up the operations of a business, and we digitally transfer the business and its strategy with the complete collaborations of an environment where ETAP provides a portfolio where you can do the planning and modeling, design and analysis, build and commission, manage and operate, access and maintain, transform and grow, and decarbonize and sustain, with an integrated multi-dimensional digital twin platform from design to operations in one portfolio. This gives the peace of mind for the developers, for the operators, for the OEMs, for the existing operating companies to correlate all the data, create a single source of information to do the complete eco cycle of the projects as well as the energy transitions. And that's where we call it as an enterprise electrical management system. So introducing ETAP GTDMS, which essentially covers from unconventional generation, transmission, distributions to the end user consumers, with a focus on the respective segments, right from the generations, which covers all the conventional generations as well as the new generations, the transmissions network and sub-transmission network, the primary distribution and the secondary distribution network, and the microgrid systems and the consumers together. So that's a unique disruption that we need today in the industry, which converges the legacy systems with the new energy grid systems. And that's what is an ETAP GTDMS to start with, which is completely hybrid yet unified with a digital twin model foundations along with the DER and an integrated function, which provides a peace of mind for the developers, for the businesses to take the right kind of investment towards the energy transitions, and yet supports on the overall operations and maintenance of the systems throughout the process. And the ETAP GTDMS is well aligned for the entire project lifecycle to the asset lifecycle, where we help to reduce the risk across the value chain of the power generation, transmission, distributions, all the way from the inception and the thought of the project to the operation, maintenance, and retirement of the assets. Where for an example, if you have a conventional power plant or an industry where you have various generators and you wanted to bring the renewable sources into it, and it is having a complex loading of an industrial sector with various inductive loads. In ETAP, we cover the platforming where you can define all the design and analytics, where you can do the feasibility studies for the steady and dynamic and transient conditions, understand the electrifications and grid interconnections analysis with the renewable controller and sources as required basis. Then as you are designing the systems and you are moving towards the operation and construction phase, the same designing which has been used by the feasibility environment goes into an operational environment where you can do the validation and tuning and be confident on the investment that you are bringing, and the mix of energy that you are going to bring in into the network will fulfill your requirement as expected basis, and have all the variability and uncertainty of renewable is tested before even if the construction, and eventually converts the same with an hardware and software in the loop simulation and validations to have the complete clarity and the tuning of the system, and eventually migrate the same platform from an design engineering environment to an operational control environment by connecting to the real-time component and getting the online informations from various renewable sources, existing generation sources, distribution networks, substations, and collecting the real-time data and training the model in order to operate on a proactive environment to provide the complete coherent operations for the plant generation management, power plant controller for the renewable systems, and combining that of getting the conventional generation and renewable energy management systems together, and eventually use it for the operators to support them on their day-to-day operations and optimize the overall operational expenses by means of providing the grid code compliances, the operator training management systems, plant settlement accounting and compliance management systems, and so on and so forth. Just like generations, the transmission grid network, again from the grid code to the transmission network analysis to the transmission SCADA to the smart asset monitoring and management systems, and for the distributions and the microgrid customers, from a distribution network designing to the extra low voltage electrical designing to the validations of the microgrid to the ADMS dumps and the microgrid functions, and eventually coming to the overall microgrid control and CMMS applications intuitive and integrated manner. So today, holistically, this is a one platform, one model, one database, one UI, which works on a foundation of digital twin, which converges your generations to the utilizations, and this is completely modular. So a plant can have the generation applications as well as the power management applications with the power analysis and the operator training in an intuitive manner, which provides a cross-functional access for various team members within the company and provides an variability to expand the systems in the future and making it a future proof of power systems and supporting your business decisions and helping in the capex and opex optimizations. And it is a unique platforming today which is disrupting the industry. And how do we do that? We do that with respect to a complete end-to-end lifecycle management portfolio. As you are going for the energy transitions for a conventional to the new energy grid, ETAP starts with a hybrid designing where you can actually do the right designing, sizing, analysis of your electrical systems and create an true native advanced electrical digital twin by coordinating and collaborating different companies or different stakeholders as engagement process basis, from a consultant to the OEM to the end users to the EPCs to the developers to the operator owner can collaborate together to do the right kind of designing and analyzing of the systems, which gives the foundation of an advanced electrical digital twin. Once you do the designing and analysis, then we can do the software as well as hardware in the loop to verify the performance while reducing the complexity, cost and time for the system commissioning and constructions. And that is the time where it goes from an hybrid designing to the software and hardware in the loop for the validations. Whatever has been designed is being constructed or not in the right way, and reduces the timing as well as provides the flexibility to do the various tuning of the different control functions. And finally, we converge the same system, same model from validations to the control and operational functions, where it essentially converges as a generation, transmission, distribution microgrid controller, where we have the soft controller converges into the real operational controller systems, which gets trained with the real-time data, communicating to the field equipment on a native industry open protocol systems, and automatically adapt and learn from the system as the changes is happening, and provides the control and optimizations of intelligence to generate the improved ROI. And finally, the enterprise electrical management system comes in, where you do the overall visualizations and management with an intelligent real-time information for situational awareness and the predictive operations and management. And that's a unique disruptive technologies which is the need of the hour in order to provide the energy transition supports, and for an existing brownfield environment where we are looking towards energy transitions, or a complete new greenfield project where we are installing an gigawatt capacity of power generations to 1 kilowatt capacity of power generations. It provides a unique opportunity for everyone to build, design, plan, operate and maintain in a very integrated manner. And that's where ETAP convergence and create an intelligent digital model as a blueprint of your plant and facilities to smart operations together. And that's where we call it as an end-to-end GTDMS applications and creation of a very unique 360-degree digital twin platform. So what is a digital twin platform? Is essentially the combination of physical, electrical, as well as real-time attributes of every single component, along with their behavioral, along with their characteristics, and along with their pattern of operations, combining together, superimposing with the real-time data as well as historical data, and training the model to take the right operational decisions by using the mathematical electrical model as well as the neural sciences for the AI and ML model, combining together provides a seamless environment for the different stakeholders in the energy transition environment to do the feasibility, to the pre-feed engineering, to the detail engineering, to the commissioning startup, to operate and optimize and train and maintain and expand the systems. So as we go through the design and building phase, where we are creating the base design twin by means of power systems modeling. So any consultant, any contractor, any OEM can use ETAP to create an electrical distribution model with all the renewable sources, all the equipment sizing, conventional model generations, creations, and so on and so forth, conduct all different type of analysis, and it provides a seamless environment to collaborate the teams across the different globes in an intuitive manner with a native cloud concept, where you can have the co-engagement and do the parallel engineering together, and then perform various power systems planning services in order to understand and do the sizing and do the right kind of power systems philosophy generations for the operational concept, and so on and so forth. by performing various steady and dynamic analysis, balanced and unbalanced analysis, electromagnetic transient analysis, and so on and so forth, and which gives a portfolio for converging and solving the unfit power systems where you have DC to AC, AC to DC. So you can do on unified power systems designing and simulations, which is just not related to power systems but also the associated process equipment, and eventually analyze the network with respect to the grid transitions for various control functions and do the designing with an automation knowledge. So while you are building your DERs on the existing systems or the existing power network where you have the conventional power systems, existing transmission and distributions, or an industrial facility and bringing the renewable, or setting up a new independent hybrid generation or an solar or wind generations as a separate utility grid system, you are designing your electrical network based on the grid code requirement while fulfilling all the expectations of the automations which is going to be deployed, as you are bringing all the automation knowledge into the designing, so that there is a very clear clarity how you are going to operate and maintain the system. And once you create a model which is basically as designed model, which is the foundation of the ETAP digital twin, it gets connected to the actual system physical equipment from substations to the inverters to the battery energy storage systems to the wind turbine generators to the governor exciter PSS and the generator control panel of the existing power generation equipments to the transmission distribution substations to all the relays, meters, and so on and so forth, and converts the same as designed SLT to an as operated model for providing power automation applications and getting into a real-time environment where you can do the validations of the as designed model into an as operated environment of control systems, where it does real-time simulations to validate all the designs have been deployed and constructed as per the defined rules or not, and then you do the tuning for your power plant control, microgrid control, base EMS control, hybrid control, and so on and so forth, which gives you an environment to tune and tweak the whole system to be operating as designed and as expected. And finally, it converges with the control center environment where you can have the entire monitoring for the SCADA, distribution management, smart city management, energy management, load shedding, load management, energy efficiency, conventional generation management to the renewable generation management together, and finally provides the management level dashboarding, reporting, integrations with various visualizations, real-time planning and simulations, asset and maintenance and planning management and information management systems. As this is an as operated model which has the mathematical electrical model, which has all the electrical, physical and every asset attributes along with the data sheet, along with the O&M informations, and it understands how it was in past, what is current and what is going to be in future. It represents all the states of your network at any given point in time, and understand your CO2 emission and how to optimize your overall power systems network. It is a portfolio which provides an complete enterprise level of electrical and power management systems, which can engage from your finance teams to your designing team to your protections team to your operations team to your safety HSC team to your management and the engineering and day in day out operations team. And that's where it provides a unique opportunity and disrupting the industries from engineering to operations in one unified platform. So as we move forward, let's look at how do we achieve it on a complete electrifications of new energy grid along with the ETAP digitalization. So what we do is we create a network model by converging all the legacy information that you have, or combination of GIS and collecting the field data. Then it goes through the design and construction phase where we do perform various power systems design analysis, which can be done in-house by your team or by a third-party consultant. Then the model is available for the day-to-day short-term and long-term planning basis, where you are converging all the again unfit power systems of unification of AC and DC, understanding of all the variables of renewable sources, and that basically gives the birth of to an integrated intelligent digital twin model, which is basically validated, and it is a blueprint of your facility for existing systems combination with the new systems from generations, transmission, distributions. to the renewable and microgrid applications, and converts that with an edge controller where it communicates natively to all the field equipment and converts the same model into an operational environment to provide a model-based SCADA HMI, and provides all the different type of event playback, root cause analysis functions, and real-time simulations, as well as a platform for operations and training and competency development management, because this is the new strategy of control. Hence, it is important for you to train the engineers to understand and operate the systems in the rightful manner so that there is no malfunction. And finally, we convert the systems into various power and distribution management systems, where you have the conventional generation management systems, load management, load shedding systems, to one distribution network analytics, to various loss minimizations, to the fault isolations, restorations, to the transmission energy management systems, and eventually creating the complete outage and operation management systems, mobile workforce management systems, and so on and so forth, which provides a complete portfolio for the field O&M engineers as well as the plant operators in order to operate the systems in a completely integrated and intuitive manner. And finally brings your renewable part into it, where you get all of your renewable energy management systems, from DERMS to renewable SCADA systems to power plant controller to pass to the microgrid function. And as we collect all of this data and informations and training the model over and over, it provides by default integrated protection, digital protection, asset safety, information management systems, as well as providing the complete advanced fault automated analysis, health monitoring and indexing, digital protection systems management, and integrates with your existing business processes and enterprise level of integrations with CIS, IVR, AMI, BI, weather systems, and generates the different situational awareness, predictive simulations, O&M planning, and analytical intelligence from ETAP management perspective. And that's basically the board for ETAP's play as an electrical enterprise management, which works on a unified digital twin platform solutions, along with all the cybersecurity compliances, from power systems design engineering to the ETAP digital twin network model management to the digital system services. So that's how the systems is converging from design construction to the operation maintenance and the management level, which shows in an integrated best-in-class GTDMS Enterprise solutions, where we create an overall GTDMS model, which has different type of electrical design analysis, protections, digital training simulations, network model management to do the right planning, and then connect to the from an enterprise network perspective, and connect to the real-time network from DER and substations, from feeder to substation automations to intelligent equipment to the renewable systems to backup BGs and the grid connections, bringing the real-time data and converging the model into a GTDMS foundations of digital twin, where we do the SCADA, DMS, EMS, DERMS, microgrid, PPC, wide area monitoring and protection automation control systems, to the mobile and cloud, and finally the integrations with the enterprise management, enterprise asset management systems, ERP, AI, MDM, energy market, work order, call management, and so on and so forth. So as we speak about the systems in totality, let's look at the GTDMS in actions very quickly. So power generation, transmission, and distributions combined. Conventional generations you already have in a plant, and then you have an existing transmission network. Then we are bringing in all the power distribution systems and connecting to the different low voltage level, and finally bringing the sources of the renewable together. So this engagement provides you a platform for combining your existing generations to the new existing transmissions, distributions to the new generations together in one model, which has all the properties, all the elements, all the real-time informations combined together with the last mile connectivity, and bringing the sources and converging the multi-physics dynamics in one go in order to provide you the right stability of your power system. So let's look at from an architectural perspective how it looks like. So in a conventional station, let's say you already have some substations and you have some generation units, and then you are adding certain renewable sources from the PV, you have energy storage systems, you have backup generators, and you have different wind sources which is available. So we basically, as an ETAP, you model all of this component which is going to come up, all your distribution transmission network, all the distribution substations, all your prosumers and consumer premises with the EV charging stations, with the rooftop solars, EV vehicles, as well as all the different metering positions which is available with the net zero and smart metering infrastructure which comes to the head-end systems and so on and so forth. So what we do is, as an ETAP, you can model the whole electrical network to understand the power flow as it is connected, and that's where you bring all of these informations together, combining into an intuitive electrical digital twin model, and that comes to one central systems where you have a digital twinning environment available to get the central SCADA by connecting to the different equipment, bringing your ADMS for the distribution side and the EMS for the existing generation side, all the central dumps functionality for the distribution energy resource management systems, providing the overall MDM, performance monitoring, protection management, workforce management, microgrid functions, integrated GIS, WAMS functions, including the asset information management functions, and connecting to the enterprise network layer. So this is the master architecture of the systems, how it can connect to different equipment, from the inverter levels to the wind turbine controllers, to the existing generator governors, to the transmission distribution systems, to the DOMs and the smart meters, and converging a legacy network into one smart utility or smart renewable network together. So if we deep dive into certain equipments, let's say distribution generations, where you have the renewable sources of PV and BESS systems. So ETAP communicates to the inverters, weather monitoring stations, trackers, auxiliary units, and bringing all of these informations, combining from the field to the ETAP digital twin model, where you are having the grid code compliance and the power analysis platforming, and communicating those together to converge it as a renewable SCADA, power plant controller, and microgrid control functions. And likewise for your existing generations, where you have the GCPs, as we model the complete generators, including their governor, exciter, power stabilizers, and the whole operational functions together, we bring into the same ETAP model in order to provide the overall generations modeling, controlling, and management systems, while we are having the BESS and solar and wind monitoring and control and management systems. And combining all of this, it goes to the central systems where you have the GTDMS applications, where you have all the different type of transmission network, from the BCUs to the relays to the breakers to the meters monitoring to the distribution kiosk and the smart meter monitoring and communications, which also gets collected the data over different protocol and sends the informations to the ETAP GTDMS. And finally the DER comes in, where you have the distributed energy resources, which is communicating over various protocol of distribution systems, and converges all of those to the central GTDMS systems. And that's how finally your GTDMS comes up, where you have the conventional generations, new energies from wind, battery to solar, your existing transmission and distribution networks, and combining all of this informations through the connected products of ETAP, where we do provide the substation automations to the control relay management systems, to load shedding applications, to metering data acquisition systems in the same integrated GTDMS model, and finally converging all of those to a substation automation and renewable solar SCADA and power plant controller, as well as the existing substations or the distributions EMCS or IPCS or substation automation or power management systems, converging and combining all of the controllers of the OEMs together, bringing to a central SCADA systems, as well as bringing all the existing systems to the same SCADA seamlessly on a modular manner, and then providing multi-site operations along with the edge controller functions. And finally it goes to the central overall GTDMS, which is an enterprise electrical management system using an ETAP digital twin platform, where The foundation is based on a digital twin GTDMS, where you would be having all the different orientations of power management of the existing systems, EMS for the existing generations and the new generations, hybrid control for the solar, wind, battery applications with an hardware and software in the loop for the RTDS to have the right kind of tuning and peace of mind for the functionalities, demand side management, load shedding applications, and load demand model creations, asset management, plant settlement management, performance management, and eventually operator training simulations to cybersecurity. So as ETAP provides a enterprise system which is completely modular, and we can choose and pick as required basis based on the industrial demand, and it is future proof for the energy transition. So if you plan today something and in 5 years down the line you are trying to bring the different sources, ETAP gives that flexibility on a central GTDMS, which is basically designed to operate. And as we discussed earlier, it's a one platform with an integrated app along with the soft controller with a digital twin foundations, which converges your existing fossil fuel generations to the new energy landscape, from renewable sources of solar, wind, or energy storage systems, to the dumps for the facilities which is on top of the consumer premises or the commercial and industrial complexes. And combining all of those together, ETAP converges as one unique platform, which brings a substantial capex and opex savings. Not only the capex and opex savings really support you to achieve your objectives and targets. What does it says? Essentially bring all of your design parameters with the automation knowledge. What does it mean? As you are planning and building your electrical network from a conceptualization stage, ETAP helps to accurately model your network, forecast the systems, run the convergence of analysis, and creates the device characteristics in the rightful manner, where you are having a digital twin state of ETAP as designed. And this is during the design phase. And due to the sizing of the equipment in rightful manner, in a very conservative manner, there is a 5% capex savings that you can get from the designing perspective. And as you go from designing to the analysis, and as you are bringing in the more generations and renewables and microgrid sources into the design, you can do further optimal design. And as designed, it goes to the as predicted, where you do the various tuning and make sure that system is expected to operate with the controller which is available in the designing environment itself, where you have not procured the systems, and behave the system's operations in the rightful manner, and optimize further and tune it further. And once your designing is over, you go through the construction phase, where you do the building and commissioning. The same platform goes from an as predicted to the as trained model. As it gets the real-time data, you can do various validations along with both sill and hill environment to avoid the costly disruptions, or to avoid any kind of penalties or the settlement issues that you might have with the utilities. And that's where you would be having the peace of mind to validate the systems and learn from the real-time data and the historical data, and savings are exceptional here. And eventually use the same platform for management and operations with the design model which you have created, gets the real-time data and the characteristics for the optimal control and the operator training management portfolio, which is very, very unique today. And you have substantial saving by bringing situational intelligence and getting an as operated environment of the model, which means you have a seamless transitions from your design construction to operation and maintenance. Multi varieties of stakeholder involvement does not make any difference, as it is a unique platform and you get the transitions at every level. And finally, as an owner, operator, developer, you use it for your day-to-day operation and maintenance perspective, where you can get all your asset conditioning, centralized monitoring and maintenance management systems, failure mode effect analysis, and do the further growth management and optimizations in the systems, where you get maximum saving of 18%. So in total, combining your capex and opex for a plant, it roughly brings up around 35% of saving at different stages of the project combined together. And that's what we call it as an ETAP GTDMS, which is again an enterprise level of electrical management systems, which is very unique today in the industry, provides all the dimensions of power systems together in one platform, converges the design to operations and creation of an enterprise system, which is available for your designing team, asset team, operations team, maintenance team, finance team, and management team for their day-to-day operation and lookout. So we are committed to converge the energy transitions and support the industry with the latest and greatest disruptive technologies. Thank you very much, and you have been a lovely audience, and thank you for your patience here.